Hi everyone. In this video, we'll be going over chapter 1.9, which is the coordinate plane, graphs of equations, and circles. So points in the plane can be identified with ordered pairs of numbers to form the coordinate or Cartesian plane. So those are just two words for the same thing, basically. Draw two perpendicular real lines that intersect at 0 on each line. So that's how we're going to just draw the graph, basically. So our horizontal line is the x-axis, our vertical line is the y-axis, and our point of intersection is at 0. So axes divide the plane into 4 quadrants. So the points that are exactly on the axes aren't in any specific quadrant. So each point in the system corresponds to an ordered pair of real numbers. So we have x and y in parentheses, and that's our ordered pair. And our x is the x-coordinate, and our y is the y-coordinate. So here, I have a picture of the different quadrants. So we have quadrant 1, quadrant 2, 3, and 4. So it goes counterclockwise. And for an example, I have -5, 3, and 3, -5 to graph on my coordinate plane. So in order to graph, my -5 is my x value. So I'm going to go on the x-axis horizontally 5 units. So I go 1, 2, 3, 4, 5. So that's my x, and then my y is 3, so I go up 3. So I go 1, 2, 3, and that's my -5, 3 point. So here, 3 is my x value, so I'm going to go right 3, 1, 2, 3, and then I'm going to go down 5 to get to -5 on the x-axis. So I go 1, 2, 3, 4, 5. There we go. Okay. Now, here's an example of describing and sketching regions. So I have my ordered pair x, y such that x is greater than or equal to 0. So let's do A first. So these are points whose x-coordinate are 0 or positive, which lie on the y-axis or right of the right axis, basically. So if our x value is 0, that's when it's going to lie on the x-axis. Because on the y-axis, sorry. Because we would just be, if our x is 0, we're not going anywhere for horizontal. So we'd just be going up and down depending on what the y is. And then it's greater than 0, which means our x values are positive. So it's going to be to the right. So that's why I have it shaded like that. B is our x and y such that y equals 1. So these are the set of points with y-coordinate 1, which is a horizontal line 1 unit above the x-axis. And that's because if we have y equal to 1, that means that we wouldn't be going anywhere horizontally. We would just stay there. And then we'd be going up 1 to get y equals 1. So we go up 1. And then all these values here have a y value equal to 1 because that's where our line y equals 1 is. So this is 1 on the y-axis. Our C is our xy such that the absolute value of y is less than 1. So y, the absolute value of y is less than 1 if and only if y is between -1 and 1. So if y is between, here's our y, because we're splitting it based on our definition of our absolute value and of our inequality. So y equals 1 is the dotted line there. Y equals -1 is the dotted line here. So our values of y are going to just be in between those. here and not include those lines. Okay, our distance and midpoints formula. So recall that the distance between point A and B on the number line is the absolute value of B minus A. So our distance formula, I'm going to explain how it's derived. So say we have an x1 and an x2 here. Our distance between those two, according to our distance formula, is the absolute value x2 minus x1. We also have points y1 and y2 on the left on the y-axis. So that distance is going to be the absolute value of y2 minus y1, And so we want to solve for the red, the distance between A and B, so points on the number line. So in order to solve for that, notice that it's a right triangle. So we have our Pythagorean theorem to solve for the hypotenuse. So we have the distance between A and B is the square root of the absolute value x squared minus x1 squared plus the absolute value y2 minus y1 squared. And that's going to get us our distance formula. So the distance between 2 points, A, which is x1 and y1, and B, x2 and y2, is the distance A and B equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to do an example. So we're going to find the distance between -1, 4, and 3, -2. So I'm just going to let x1 and y1 be -1, 4, and x2, y2 be 3, -2. So we're just going to plug them into our formula. And so we get the square root of 16 plus -6 squared. That's going to be the square root of 16 plus 36 equals square root 52. We could split this up into the square root of 4 times 13 using our radical properties. And then I get 2 square root 13. So here on the left, I have a diagram of what this looks like. So I have my 2 points, and then I'm finding the distance between them, which is 2 to the square root 13 units. Okay, now we're going to look at our midpoint formula. So we're going to find the midpoint of a line segment between two given points. So the midpoint is basically the point that splits the segment into two equal sections. So the midpoint of a line segment from A, x1, y1 to B, which is x2, y2, is going to be taking the average of the two x coordinates and the two y coordinates. So we're going to do x1 plus x2 divided by 2 and y1 plus y2 divided by 2 to get our coordinates, our x and y's. So we're going to show the quadrilateral with vertices 1 and 2, 4 and 4, 5 and 9 is a parallelogram by proving that its two diagonals, S, 2 to 7, bisect each other. So if the two diagonals have the same midpoint, then they must bisect each other. Alright, so we're going to find the midpoint of PR. So PR is this diagonal, and then SQ is this diagonal. So right now we're just going to find PR. So our midpoint of PR is 3 and 11 over 2. We find that because for P we have 1 and 2, and then our R we have 5 and 9. So I'm doing the X values 1 plus 5 divided by 2. The Y values 2 plus 9 divided by 2. Okay, so that's my midpoint. And then my midpoint of QS, I'm taking Q, 4 and 4, and S, 2 and 7. So I'd take my X values, 4 and 2, my Y values, 4 and 7, and I get 3, 11 over 2. So each diagonal bisects each other because their midpoints are the same. Alright, now we're going to go over graphs of equations in two variables. So equation in two variables expresses a relationship between two quantities. So for example, my y equals x squared plus 1. So my two variables are my x and my y. and that equation represents the relationship between them. So point xy satisfies the equation if it makes the equation true when the values for x and y are substituted in. So here an example, I have 3, -5, and my equation is y equals 4 minus x. So when I plug my x and y in, it's good, it checks out. So 3, -5 is a solution. So when we have equations and points, we're able to make graphs. So the graph of an equation in x and y is the set of all points x, y in the coordinate plane that satisfy the equation. So here, my example is I'm going to sketch a graph by plotting points. So I have 2x minus y equals 3. So I'm just going to solve for y first. So I'm just going to subtract. I'm going to subtract 3 from the right hand side. So I'm going to get 2x minus 3 minus y, and then I'm going to add y to the right hand side. So I get y equals 2x minus 3. Okay, so I have a table here where I have different x values, and then so these are my different x values that I'm going to have, and I just chose basically like values around 0, -1, and 1 just to see what the graph looked like. Here is me solving for the y values by plugging in my x values from there. So I'm going to plug them in, and then here's just my ordered pair. So I take my x and my y and I combine it to make the ordered pair. So after I come up with all my ordered pairs, after plugging in the x's to solve for the y, I graph it on my graph. So each of these points is one of the points from the tables. And then I'm just going to draw a line through all the points. Alright, so my next example is 4 minus x squared. So I have all my x values here, and then I solve for my y values. So like for x equals -3, I do 4 minus -3 squared equals 4 minus 9, which is equal to -5. And then I build up all my ordered pairs, and then I plot them, and then I draw and connect the dots. And when I connect the dots, I'm going to go basically from the left to the right. So I'm not connecting this dot with like the one all the way across or anything. So I'm connecting from the x values increasing. Okay, here I have my x equals the absolute value, or my y equals the absolute value of x. So I have my different x values. Y equals absolute value x. So when I plug in my x values, they're all going to be positive, my y values. I have my ordered pairs, and then I just graph them, and then I connect the dots. So these are just some classic graphs that we're always going to encounter. We have the linear equation here. We have a parabola there, which is quadratic. And then here we have an absolute value, which is always like in the shape of a V. Okay, so some things that we could tell from graphs are like the intercepts. So we have our x-intercepts, which is the y-coordinates of the points where the graph intersects the x-axis. And this is obtained by setting y equal to 0, because our y-coordinate is always going to be 0. So for example, in the graph 4 minus x squared equals y, it crosses the x-axis at -2, 0, as we could see up here. Crosses at -2, 0. So the x-intercepts, and then it also crosses at 2, 0. So our x-intercepts are -2 and 2. So our y-intercept is the y-coordinate at the points where the graphs intersect the y-axis. And this is obtained by setting x equal to 0, because our x-coordinate is always going to be 0. So for example, our graph 4 minus x squared crosses the y-axis at 0, 4. So its y-intercept is 4. So now we're going to find intercepts. So find x and y-intercept of a graph y equals x squared minus 2. So this time we're going to find them algebraically and not through a graph. So for our x-intercept, we set y equal to 0. solve for x. So I have 0 equals x squared minus 2. I have x squared equals 2 because I moved the 2 over by adding it. And then I have x equals plus or minus square root 2. So those are my x-intercepts. And they're going to be in the form like this. My y-intercept, I set x equal to 0, then I solve for y. So x equals 0 squared minus 2. So x equals 2, and that's my y-intercept, which is in the form of that. Alright, so a cool sort of graph here is a circle. So a circle is a set of all points in a plane that are equidistant from a fixed point, and this fixed point is called the center. So the fixed distance from the circle center to any point in the circle is called the radius. So the equation of a circle with center hk and radius r is x minus h squared plus y minus k squared equals r squared. So that's the standard form of the equation of the circle. And if the center of the circle was the origin 0, 0, then the equation would be like x squared plus y squared equals r squared. So here's like a picture of it. I'm going to show a graph here for our next example. So my center is negative 2, 3. So I have negative 2, 3. That's my center. My radius is 4. So I have 1, 2, 3, 4 going up there. So go that way. Then I have 1, 2, 3, 4. That way, 1, 2, 3, 4 over here. And then 1, 2, 3, 4. So it's a pretty big circle. Oh, my circles are never perfect. So that's okay. Alright. Alright, so we want to write the standard form of the equation of the circle with center negative 2, 3 and radius 4. So we know our h is negative 2 here because negative 2, 3 is like hk. And then k equals 3 and then r equals 4. So we just plug those into our standard form of the equation. So we have x minus negative 2. And remember, it's x minus h, and our h was negative 2. So make sure to put parentheses around those so you don't mess up the negatives. So it's x minus negative 2 squared plus y minus 3 squared equals 4 squared. So x plus 2 squared plus y minus 3 squared equals 16 is our standard form of the equation of the circle. So now we're going to find the center and radius of the circle, whose equation is x minus 2 squared plus y plus 4 squared equals 9. And then graph the equation and find the domain and range. So we have x minus 2 squared. So that's the same thing. So this is the x minus h squared. So our h is 2. Y plus 4 squared, that's supposed to be y minus k squared. So our k is actually going to be negative 4. Don't forget that, and don't say the k is 4 because we have the minus k here. So our k is negative 4, which ends up making it positive for y plus 4 squared. And then 9, remember 9 is r squared. Therefore our r is 3 because 3 squared equals 9. Okay, so our center is 2, negative 4 with radius 3. So we plot our circle. So we have our center at 2, negative 4. And then I go out 3 units from all directions in order to draw the circle. And so our domain is negative 1 to 5. And then our range is negative 7 to negative 1. So our domain here I highlighted yellow. And then our range here I highlighted with like the light green. So we're able to tell that because like if we drew like dotted lines here, that's our domain. And then if we drew dotted lines here, that's like our range values. Alright, so symmetry. So we have 3 different kinds of symmetry. Usually, so we have symmetry with respect to the y-axis, with the x-axis, and about the origin. So if we have symmetry with respect to the y-axis, if we have a point xy, an ordered pair, that means that it's symmetrical to the other point, which is negative xy. So it's like the mirroring. And then with respect to the x-axis of point xy, that would be mirrored with the point x of negative y. And then if it's symmetric with respect to the origin, the ordered pair xy is symmetric. So it's like a 180 sort of rotation, and that is negative x, negative y. So here's an example here. We have our classic parabola, y equals x squared. So this is symmetric about the y-axis because we have our point here, x, y, and then we flip it across. So imagine taking this point, you flip it, you mirror it. So this green here, that's my axis of symmetry. So that's what I'm flipping over. So as you can see, like whatever's on the right side of the graph of the axis of symmetry, it looks the same as what the left side is, just flipped. So this is just a table of our different symmetries. So in order to test whether it's symmetrical with respect to the x, y, or origin, these are the tests that you could run. So if we replace y by negative y or x by negative x, and if the result is similar to the original equation, that's how we could tell if it's symmetrical to the x or y axis. And then in respect to the origin, you replace both x by negative x and y by negative y, and if the result's the same as the original equation, then it's symmetrical about the origin. So we're going to have an example here. I'm going to test x equals y squared for symmetry, and then I'm going to sketch the graph. So I'm going to replace y by negative y in the equation to check if it's symmetrical about the x-axis. So when I plug in negative y, I get x equals y squared, which is the same as this. So it's symmetric about the x-axis. So let's check our x replacing by negative x to see if it's symmetric about the origin. So we have negative x equals y squared, which is not equivalent. Therefore, it's not symmetric about the y-axis, and it's also not symmetric about the origin. Not symmetric about origin. So we're going to use the symmetry about the x-axis to sketch our graph just by plotting points for y greater than 0. Okay, so I have my y here, and I have different points for my y. So I have, okay, I'm going to change that y because that's not a good y. Okay. So I have 0, 1, 2, and 3 for my y values. I'm going to find the x values that associate with that. So I have 0, 1, 4, and 9 when I square those. So I have my different ordered pairs. So I have 0, 0, 1, 1, 4, 2, and 9, 3. And that's my red, the above. So since it's symmetric about the x-axis, that means that we also have the same for like positive x's. So we have x, y, and when it's symmetric about the x-axis, we also have the points x, negative, y. So I basically just kept the x's the same, and then I negated the y values. So we don't have to go in and solve for them again. I just made the y's negative, and then I plotted them. Okay, that's it. I'll be posting this today, and then I also on Wednesday make sure to check out the readings. I believe it's section 1.10 to 1.12, and I'll be posting those soon. Thanks. See you then.